NEC 210.6c addresses branch circuit supplying outdoor, portable or cord-connected luminaires, mandating ground fault circuit interrupter protection for personnel. NEC 210.6d concerns pole-mounted luminaires, stipulating that they be supplied by a branch circuit protected by a ground fault circuit interrupter if the luminaire is accessible to unqualified persons. These unqualified persons are often members of the general public. These sections of the National Electrical Code apply to both street light poles and highway signs, provided certain conditions are met. Firstly, the installation must be outdoors. Secondly, it must be either portable or cord-connected, which is particularly relevant for highway signs. Thirdly, and crucially, the equipment must be accessible to unqualified persons. Now, let's consider the specific case of a 15-foot street light pole with ballast and luminaire operating at 480 volts. Is this permissible under NEC 210.6c and d? The answer is yes, it is permissible, but with a critical condition. The branch circuit supplying the luminaire must be protected by a ground fault circuit interrupter. This is important because while the 480 volts operation might seem inherently dangerous to the public, street light poles are generally not considered accessible to unqualified persons. Because of this inaccessibility, the requirement in 210.6d regarding ground fault circuit interrupter protection might not automatically apply. However, local codes or specific installation circumstances might change this assessment. Therefore, always consult local regulations and conduct a thorough risk assessment. Regarding highway signs, the situation is slightly different. Highway signs are very often cord-connected. Additionally, they are often situated in locations where they are accessible to unqualified persons. Given these two factors, the branch circuit supplying a highway sign must be protected by a ground fault circuit interrupter. This requirement stems from both 210.6c due to the cord connection, and 210.6d due to the accessibility to the general public. To summarize, a 15-foot street light pole operating at 480 volts is permissible if the branch circuit is protected by a ground fault circuit interrupter. For highway signs, ground fault circuit interrupter protection is mandatory if they are cord connected and accessible to unqualified persons, regardless of the operating voltage. Now let's delve deeper into the technical considerations and practical applications of these code requirements. We'll discuss the selection of appropriate ground fault circuit interrupters, the methods of ensuring accessibility, and the impact of different installation scenarios. Firstly, the selection of a suitable ground fault circuit interrupter is paramount. The ground fault circuit interrupter must be rated for the voltage and current of the branch circuit. Furthermore, it must have an appropriate trip threshold to provide adequate protection without causing nuisance tripping. Ground fault circuit interrupters come in various types, with different trip current settings and response times. For personnel protection, the classic ground fault circuit interrupter is typically required. Classic ground fault circuit interrupters trip when a ground fault current of 6 mA or more is detected. It is important to select a ground fault circuit interrupter that is specifically designed for use with luminaires and that can withstand the transient voltages and currents associated with lighting circuits. Secondly, the concept of accessibility to unqualified persons requires careful consideration. The National Electrical Code does not provide a precise definition of accessible to unqualified persons. However, the intent is to protect individuals who are not familiar with electrical hazards and who might inadvertently come into contact with energized parts. Factors that influence accessibility include the height of the equipment, the presence of barriers or enclosures, and the level of security in the area. For example, a street light pole located in a remote area with no public access might be considered less accessible than a highway sign located adjacent to a pedestrian walkway. The use of physical barriers, such as fences or enclosures, can reduce accessibility and potentially eliminate the need for ground fault circuit interrupter protection. However, the effectiveness of these barriers must be carefully evaluated to ensure that they adequately prevent access by unqualified persons. Thirdly, different installation scenarios can significantly impact the application of NEC 210.6c and d. For example, A street light pole that is installed on private property with restricted access might not be subject to the same requirements as a street light pole that is installed on a public street. Similarly, a highway sign that is powered by a low voltage power supply might not require ground fault circuit interrupter protection, even if it is accessible to unqualified persons. It is essential to carefully evaluate the specific circumstances of each installation to determine the appropriate level of protection. In addition to the requirements of NEC 210.6c and d, there are other relevant code sections that must be considered when installing street lights and highway signs. These include NEC 410, which covers the installation of luminaires, and NEC 600, which covers the installation of electric signs and outline lighting. NEC 410 provides detailed requirements for the wiring, support, and grounding of luminaires. It also addresses the use of suitable enclosures and the protection of conductors from physical damage. NEC 600 provides specific requirements for the installation of electric signs, including the use of overcurrent protection, disconnect switches, and grounding electrodes. Furthermore, it is important to consult local codes and regulations, as these may impose additional requirements beyond those specified in the National Electrical Code. Local codes may address issues such as the height of street lights, the spacing of luminaires, and the use of energy-efficient lighting technologies. Now, let's consider some practical examples of how these code requirements apply in real-world situations. Firstly, consider a street light pole that is located in a residential neighborhood. The pole is 15 feet tall and is powered by a 480 volts branch circuit. The luminaire is accessible to unqualified persons as it is located in a public area. In this case, the branch circuit supplying the luminaire must be protected by a ground fault circuit interrupter, in accordance with NEC 210.6d. The ground fault circuit interrupter should be installed in a readily accessible location, such as a service panel or a disconnect switch. Secondly, consider a highway sign that is located adjacent to a highway. The sign is cord connected and is powered by a 120 volts branch circuit. The sign is accessible to unqualified persons as it is located in a public area. In this case, the branch circuit supplying the sign must be protected by a ground fault circuit interrupter, in accordance with NEC 210.6c. The ground fault circuit interrupter should be installed in a weatherproof enclosure to protect it from the elements. Thirdly, consider a street light pole that is located on private property with restricted access. The pole is 20 feet tall and is powered by a 480 volts branch circuit. The luminaire is not accessible to unqualified persons as it is located behind a locked gate. In this case, the branch circuit supplying the luminaire may not require ground fault circuit interrupter protection, as the luminaire is not accessible to the general public. However, it is still important to comply with all other applicable code requirements, such as those pertaining to wiring, support, and grounding. In conclusion, NEC 210.6c and d provide important safety requirements for street lights and highway signs. By understanding these requirements and applying them correctly, it is possible to ensure the safety of both qualified and unqualified persons. Remember to always consult the latest edition of the National Electrical Code and to consult with a qualified electrical inspector to ensure compliance with all applicable codes and regulations. It is also important to consider the specific circumstances of each installation and to exercise good engineering judgment when making decisions about electrical safety. Safety should always be the top priority when working with electricity. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following safe work practices. Never work on energized equipment unless you are properly trained and qualified to do so. If you are not sure how to safely perform a task, consult with a qualified electrician.